Hello, this is the third video in the Roots series of OCR Pure Core AS Further Maths. It will look at how to form equations with related roots. Here is a reminder of sessions 1.1 and 1.2 where we saw that for quadratic equations these relationships hold. If you need to make a note of these for yourself for use later in the session, please do so quickly now. Let's look at this example where we have an equation 3x squared plus 2x minus 6 equals 0 with roots alpha and beta. We need to find an equation with roots 3 alpha and 3 beta. Let's start by considering what we do know. If we have that a equals 3, b equals 2 and c equals minus 6, then we know that alpha plus beta equals minus b over a equals minus 2/3, and that alpha beta equals c over a minus 6 over 3 equals minus 2. If the equation has roots 3 alpha and 3 beta, then we know that the sum for that equation will be 3 alpha plus 3 beta, or 3 lots of alpha plus beta, which would be 3 lots of minus 2/3, which would be minus 2, which will be, if you like, the new minus b over a for this new equation, and that the product will be 3 alpha times 3 beta, or 9 alpha beta, which will be 9 of minus 2 equal to minus 18, which will give us our new c over a for this new equation. It says an equation, not the equation, because of course we haven't chosen the value of a yet. If we were to choose the value of a equals 1, then we would have an equation with roots 3 alpha and 3 beta of x squared minus 2x plus minus 18 equals 0, or in other words, x squared plus 2x minus 18 equals 0. If we had chosen a to be a different value than 1, we would have a multiple of that equation. If we look at the graphs of y equals 3x squared plus 2x minus 6 and y equals x squared plus 2x minus 18, we can see the relationship between the roots, i.e. that the roots are 3 times the value. How else are the graphs related? You may wish to pause here and think this through for yourselves. If you consider a mapping between f of x to f of 3x, in other words, we are replacing x by 3x, then let us consider, for example, if we look at x squared plus 2x minus 18, that would translate to being 3x all squared plus 2 lots of 3x minus 18, which would give us 9x squared plus 6x minus 18, and which is of course 3 lots of 3x squared plus 2x minus 6. Thus we can also see that if we had gone from f of x mapping to f of x over 3, we would have gone from this 3x squared plus 2x minus 6 to this relationship here. Thus you might like to think that an equation with roots of multiple m times the roots is a transformation or stretch of f of x to f of x over m. You may remember from the last session the trick of finding equations with roots alpha squared and beta squared. To find an equation with roots alpha squared and beta squared, we can use nearly the same method as we did in session 1.2. Here we looked at the fact that alpha squared plus beta squared equaled alpha plus beta all squared minus 2 alpha beta. We know that alpha plus beta equals minus 2/3 and that alpha beta equals minus 2. Therefore alpha squared plus beta squared will equal 4 over 9 plus 4, or in other words 40 over 9. Which gives us our new sum, or the minus b over a, for our new, or one of the new equations we could find. The product, alpha squared beta squared, will equal alpha beta squared, which will equal 4. So our new c over a will equal 4. Therefore, an equation, if we take a equals 1, will be x squared minus 40 over 9 x plus 4 equals 0. It's probably better to take a as 9 here for neatness, which would give us 9x squared minus 40x plus 36 equals 0. Just to reiterate, we've used previous results that we knew for the first equation to produce the minus b over a and c over a results for an equation with roots alpha squared and beta squared. Okay, an equation was the x squared minus 40 over 9x plus 4 equals 0, but if we choose a equals 9, it gives us an equation without any fractions. So in other words, 9x squared minus 40x plus 36 equals 0. Here is a reminder of the relationships we found in previous sessions for cubic equations. If you need to make a note of these on a piece of paper for yourselves, please pause and do so quickly now. Here we have an example with this cubic equation, where we can see that a equals 2, b equals minus 5, c equals minus 1, and d equals 6. We're asked to find an equation with roots which are double the size of the roots alpha, beta, and gamma. So let's consider the sum for the new equation. I'm going to have 2 alpha plus 2 beta plus 2 gamma, which is twice the sigma alpha I had before. I'm going to be very careful with signs here. So that's twice minus 5 over 2, which gives me 5, which will lead me to my new b minus b over a. When I look at the pairwise, I'm going to have 2 alpha 2 beta plus 2 beta 2 gamma plus 2 gamma 2 alpha, which in other words will give me 4 of my sigma alpha beta, or 4 lots of minus a half. It's minus 2, which will give me my new c over a. And then the product, I've got 2 alpha times 2 beta times 2 gamma, or in other words 8 alpha beta gamma, which equals 8 lots of minus 6 gives me minus 24, which gives me my new minus d over a. So a or an equation, if I take a equals 1, will be x cubed minus 5x squared minus 2x plus 24 equals 0. So here's a slide just giving a slightly clearer explanation of where we used the roots of the original equation to get some of those values. And here it continues on a second slide to get the same result as I showed you before. In this slide we can see the relationship between the two graphs. You may remember in earlier that we looked at the relationship between graphs and the fact that you would end up with a transformation or stretch parallel to the x-axis with a scale factor of previously of a third, and here in this graph you may like to pause and think through for yourself what the relationship is. So just quickly considering that we have 2x cubed minus 5x squared minus x plus 6 equals 0, and then the other graph is x cubed minus 5x squared minus 2x plus 24 equals 0. If we think of it as a mapping or transformation from f of x to f of x over 2, then that's going to be a stretch parallel to the x-axis of scale factor 2. So let's just plug in that x over 2 into that first equation. So if we looked at 2x over 2 cubed minus 5x over 2 squared minus x over 2 plus 6, we would have x cubed over 4 minus 5x squared over 4 minus x over 2 plus 6, which as you can see is a multiple of this second equation here. If we multiply through by 4, we would get that second equation. Don't worry if this is a little bit confusing at the moment. We'll be looking at it again in the next session. In session 1.4, we will cover how to form equations with related roots by substitution.